So in this video, we're going to talk about absolute value functions. And in the first two examples, we're just going to review what absolute value means. Remember, absolute value tells us the distance from 0 typically. So when I tell you to find the absolute value of 6, what I'm doing is I'm asking you to find the difference between 0 and -6, or another way I can say it is the difference between -6 and 0. But either way, that distance is going to be 6. So when I ask you to find the difference between two numbers, you're going to subtract them and put them on the inside of the absolute value. And whatever that distance is, that's what the absolute value is going to be equal to. So in this example here, it says, describe all numbers of x that are a distance of 5 from the number 12. So we want the distance to be 5. And any of the numbers that we're calling x, we want that distance between x and 12, which is the difference between x and 12, to be 5. So we're going to write it like this. Whatever number I put in there for x, the difference between that number and 12, that distance should be 5. So in the next example, very similar. Describe all the numbers of x that are a distance of 1/11th away from the number 3. So whatever that value of x is, I want to find the difference between x and 3, and I want that distance to be 1/11th. Okay, now going on to graph absolute value functions. In general, my absolute value functions will look like this as far as the equation. A will tell me the vertical stretch or shrink, but it will also tell me which way the V is which way the V is facing. So absolute value functions look like a V. If A is positive, it's going to be facing up. If A is negative, the V is going to be facing down. And your HK is going to be your vertex. The other things that you need to find when you're graphing any function in general, your x and y intercepts. And just a quick refresher, your x-intercept is the value of x when y is 0. And your y-intercept is going to be the value of y when x is 0. So let's look at this first example. We need to find all the key parts. So if I look at this, it looks like my A is 1. My H is going to be -1 because I can rewrite this plus as a double negative. I can write it as x minus a -1, which would make H -1. And my K would be 0 because even though we don't write it in there, it's a plus 0. So I know my vertex is going to be -1, 0. And I know because A is positive that my V is going to be facing up when I graph this. The next thing I need to find is my x and y intercept. So I need to find the value of x when y is 0. So here's my equation. I need to plug in 0 for y and figure out what x is. Well, x would have to be -1. So my x-intercept is at -1. My y-intercept is the value of y when x is 0. So if I look at my equation, I'm going to plug in 0 for x, and that's going to give me a 1. So that's my y-intercept. So when I put this all together, I have my y-intercept, which is at 1. I have my x-intercept, which is at -1. And I have my vertex, which is at -1, 0. Here's my vertex right here. It happens to be that my vertex and my x-intercept are the same value in this case. And I know since this is going to be a V shape and it's going to be facing up, and I can use symmetry, if I imagine I have this dashed green line coming through my vertex, I can figure out that my other point, without doing any math, just looking at the distance from here to here, has to be the same as the distance from here to here to get my V. Here's my V shape. So don't forget that absolute values are symmetric with that line of symmetry coming up through the vertex. So if you don't have enough points to plot, you can use that symmetry to plot points on the other side of that line of symmetry to complete your graph. Okay, next example. I have y is equal to the absolute value of x minus 4. So a is 1. Even though we don't write it in there, I know it's a 1 times in front here. That's my a. Remember, here is my general form. So my number that's in front is 1. My h is 0, and my k is negative 4. So I know my vertex is going to be at 0, negative 4. And I know it's going to be facing up because my a is positive. So when I graph my v, it's going to be facing up. So let's find my x-intercept. My x-intercept is the value of x when y is 0. So I'm going to plug in 0 for y and solve for x. Because this is absolute value equation, remember we have to isolate the absolute value. So I'm going to add 4 to both sides, which means x has to be plus or minus 4. If I put in positive 4 and I take the absolute value, I get 4. And if I plug in negative 4 for x, I get the absolute value of negative 4 is 4. So here, in this case, I have 2 x-intercepts. Okay, now I have to find my y-intercepts. That's the value of y when x is 0. So I have to plug in 0 for x. And I'm going to discover that my absolute value of 0 is 0, and then I subtract 4, and my y-intercept is negative 4. So when I plot all this on my graph, here's my y-intercept at negative 4. My 2 x-intercepts are at positive and negative 4. My vertex is at 0, negative 4. So my vertex in this case is my y-intercept. And when I put that all together, I get my v. Okay. Example 3. We have y is equal to negative absolute value of x plus 1. In this case, my a is negative 1, so I know when I graph it, I'm going to have an upside down v. My vertex, or my h and k, is going to be 0 and 1. Now I got to find my x-intercept and my y-intercept. My x-intercept is the value of x when y is 0. So I'm going to plug in 0 for y. I've got to isolate my absolute value. So I'm going to subtract 1 from both sides. And then divide both sides by negative 1. So I get the absolute value of x is equal to positive 1, which means x is going to be plus or minus 1. Because if I put positive 1 in for x and I take the absolute value, I get positive 1. And when I put in negative 1 for x and I take the absolute value, I still get positive 1. So here are my x-intercepts. Here's my vertex. And I just got to now find my y-intercept. My y-intercept is the value of y when x is 0. So I'm going to plug in 0. And that's going to give me a y is 1. So when I put this all together, I get my y-intercept is 1. I get my x-intercepts are positive and negative 1. My vertex, which happens to be the same as my y-intercept, is right here, x 0, 1, and here I got my upside down v. Okay, one more graphing example. Let's see, I have y equals the absolute value of x plus 3 and then plus 1. So my h is going to be negative 3 and my k is going to be positive 1. So my vertex is going to be at negative 3, 1. My x-intercept is the value of x when y is 0. I'm going to plug in 0 for y and solve for x. I got to isolate my absolute value, so I'm going to subtract 1 from both sides. The absolute value of x plus 3 is equal to negative 1. That tells me that's impossible. There is none. That is because if I take an absolute value of something, it's always going to be positive. So in this case, we have no x-intercepts. For my y-intercept, that's the value of y when x is 0. So I'm going to take 0 plus 3 is 3. When I take the absolute value of 3, I get 3. And then I add it to 1 and I get 4. So my y-intercept is at 4. Because my value of a that's in front of my absolute value is positive, I'm going to have my v shape is going to be facing up. My vertex, my point, is going to be at negative 3, 1. And this is a case where I don't have enough points, this is my vertex right here, to draw it right away. So I'm going to think about my line of symmetry. So here's my dashed line of symmetry. If I come out 1, 2, 3 points this way, then I should come out 1, 2, 3 points this way. So I should also have the point negative 6, positive 4 on this graph to complete my graph. And I can always go back in and plug the negative 6 in for x to make sure I get out 4 for y. If I plug in negative 6 for x, negative 6 plus 3 gives me a negative 3. When I take the absolute value of negative 3, whoops, that should be a 1. Hold on. When I take the absolute value of negative 3, that gives me positive 3. And when I add that to 1, I get 4. So there's my completed graph. Okay, last two examples, which is thinking questions. It says, find all the values of a, meaning this a right here, in interval notation so that there are no x-intercepts for f of x is equal to 3 times the absolute value of x plus 1 plus a. Now, this tells me here, since it's positive, that my graph is going to be facing up. This tells me that my h is going to be negative 1. This is my value of k of my vertex. So I need to figure out what values in here would work so that I would get no x-intercepts. Well, I want to make sure that this a is above 0. I don't want it to touch the x-axis at all so that I don't get any x-intercepts. So if I say that a is greater than 0, not equal to 0, because then it would touch the x-axis. I want it to be strictly greater than 0, so then it bumps up and it never touches here. So to put that in interval notation, it would be from 0 infinity, not including 0 with the parentheses, anything greater than 0. So it could be 0.1, but it can't be 0. Okay, last example. It says the same idea, it's taken the same function, 3 times the absolute value of x plus 1, and then add a, what are the values of a that this could be so that we have no y-intercepts? This one is impossible, because no matter where I put my v, whether it's here, whether it's here, it's always going to cross the y-axis at some point. So there is no value of a that I could set in there that would give me no y-intercepts. So I would write impossible or undefined or DNE does not exist. So these are all good thinking questions to get you to understand how the equation matches up with the graph and how those letters, like the A and the H and the K, how that affects the graph when you change those numbers.